In his role as a senior DevOps engineer at SAP Labs India, our next speaker manages and supports DevOps for SAP ABAP on Cloud Foundry and Kubernetes platform. He is actively involved as a community member and speaker with CollabNix, ConfHub, and Cloud Native Data Management. He is a microblogger on many social platforms where he keeps posting around the best practices, security, cloud native application modernization, and implementation of DevOps tools and technologies. And now he is waiting to grab your attention and share his tech thoughts on the best practices natively implemented to secure Kubernetes cluster. Ladies and gentlemen, please give a warm welcome to Mr. Suman Chakraborty.
Today, I am going to present a topic on implementing the best practices to secure your Kubernetes cluster. So in this topic, I'm going to basically take into some of the key factors which is responsible in managing your Kubernetes securely from any impeding malicious activities and breaches. So coming into myself, so I'm basically working as a senior DevOps engineer with SAP Labs India, and I'm a community member and speaker on various cloud native groups, including Docker Bangalore and CNCF, and I've spoken in many CNCF events also. I'm a part-time tech blogger on PaaS, cloud native, and microservices, and you would often find me posting articles around them on my social handler platform. So coming into the current state of security. So basically to understand the current state of security, we have to understand that what is that which impacts the Kubernetes cluster. So if I say Kubernetes is a distributed system where there can be incidents of security across every components. So a recent survey published by StackRox shows that 94% of the organization has reported security incidents in the last 12 months, out of which 69% were attributed to the configuration side issues, while 27% were attributed to the runtime security and 24% on the image vulnerability. So if I see the timeline from in the last year, like from last year, from 2018 to 2019, we can see there has been a lot of incidents which has been reported. One of the major incidents and that basically had a deeper impact on the cloud native area was the cryptojacking in the Tesla, which was really created through some open API connection to the control plane from China to get the informations. There were incidents reported around the database side like HCD, where there were certain credentials leaked, incidents reported around the Kubernetes dashboard accessibility, around on the container runtime vulnerability, and even there was incident reported in managing the Kubernetes side of actions, like sending data from the host to the containers. And even the Kubernetes API server has reported to receive many DDoS activities. So, well, if I say we need to stringent our implementations to make the cluster more secure against this kind of robust attacks. So just trying to break the basics, I'll just take a few time to explain like how we basically understand that which level of security we need to implement. So coming into the side, if we think about from a very large implementation, so we have something called as a project that is implemented on an infrastructure as a service side, where we can implement strongest network isolation, data isolation, metadata isolation. From there comes the cluster. So in case of a AWS cloud provider and Azure, they have the managed cluster, managed services on Kubernetes. So this cluster side is then they are actually providing or they are managing it for you. But if you are having an on-prem deployment or you are basically managing it on your own private cloud infrastructure, this is something you should manage. Like it should also refers to the control plane isolation, the network isolation, the data isolation. From there comes the node. Node is something where you are actually deploying your work on the application pods where you are actually running the containers, and the node is something which really so here you should have a stronger resource isolation and a data isolation. And in case of pod which are deployed across the namespace by default automatically gives a singular layer of isolation between the pods that are running. And so here what you can ensure that you should have a strong pod security policies and the service account implementation that you can actually do on your pod level. At the container level where you have actually deployed your application, the main thing is securing your resources, securing the kernel that the container can access to. And that implies that you should be using the image, a proper image, and also you should ensure limited access to the surface area where the container is being deployed. So before we jump into the security side, what factors we consider here before doing that? So the things that comes is like whether we have reviewed access right to the cluster to understand the potential inside and attack vectors. Do we have visibilities of the Kubernetes pod which are being deployed? So either we are able to see those pods, or it's just that we know that they are running somewhere and we want to really do certain actions on them. Do we have a way to detect any bad behavior among the east-west traffic? East-west traffic is something which manages the traffic from the pods across multiple node machines. So are you able to monitor what is going inside a pod or container to determine if there's a potential exploit? And how do you basically imply or implement security alerts for the operation team so that they can be quickly informed if there is a breach that is happening? How do you segment particular containers or network connections in a Kubernetes kind of an environment? Okay, so thinking about that, the obvious question comes, do I know Kubernetes security? So let us think from the hacker's point of mind, how like he will try to do certain hacking or try to basically try to cause certain issues on the cluster side. So from the hacker's point of mind, there are three areas of inception. First is the control plane, second is the networking, and third is the workloads. From the control plane side, it's more about managing the TLS encryption, the RBAC management, the rotating the encryption keys that are being used for the certificates. From the networking side is basically the node-to-node communication, the node-to-pod communication, and the firewall policies which are being set. While from the workloads is about securing your container image, ensuring that you use an image which doesn't have any vulnerable code injected. Okay, you should ensure that that particular image has been scanned thoroughly before it is being deployed on the Kubernetes cluster. You basically provide limited access on the pod boundaries for the hackers to get any unsolicited access to the application side. And also you provide you basically allow users to like log in using a non-root user. Okay. So understanding then what are the key KATS vectors. So basically there are different points where actually data injection or security can be breached. So coming into that, first thing that comes, it's the Kube API server, which is basically the front-facing API which takes requests from the end user to do certain actions or to basically carry out certain tasks. So we need to access or we need to secure that API access or the proxy from where the request is received. Coming into the HCD, then again, we have to ensure that we have a strong policy set around it so that the data is secured inside that particular database. In the node side, basically the kubelet is the part which really manages the lifecycle of the pod which is deployed on the node, and you should ensure that the kubelet has limited functionality in terms of basically ensuring that it can only run the set of actions which it is intended to do. So you should try to secure the API endpoint of the kubelet. Next comes is basically the application which are being deployed in the container. So as there are two important things here. First is you should ensure that you always try to run a more correct image. I mean, that is free of any vulnerable code. You should also ensure that the image that is deployed in a container is being accessed directly using a non-root user. So basically, the idea here, as the thumb rule says, that to provide security, you should have basically a limited surface area and also provide least access privilege to the users accessing to your cluster. Now, coming to the main points, understanding like how this fits into. So first is the Kubernetes API server. So API server, as I told you, is a REST API for the Kubernetes environment that accepts the request that is being sent by the end user. So you should have a TLS encryption that should be provided for all the API traffic that you are running. All the API clients must be authenticated, even like those parts like of the infrastructure such as node proxies and the scheduler and the volume plugins. The API calls also need to be authorized. Preferably, you should use a RBAC component to define certain policies for the users who are accessing that API call. You can also basically integrate the Kubernetes API with a third-party auth provider such as a Google or a GitHub that allows to configure the Kubernetes API to add or remove users. It then is not headache from your side to manage it, but it's those third-party providers that will manage for you. Next thing comes is enabling the RBAC with the least privilege and disability ABAC. So ABAC is something which was called as the attributed access control. It didn't provide fine-grained controller policy, and so it was replaced with version 1.1.11 with RBAC, which is more of a role-based access control implemented specific to an user for an application which is deployed onto a particular namespace. You define certain set of actions in terms of the verbs, like what that particular user wants to do. And so the default RBAC settings only allow limited API access for the anonymous user. You can basically set the authorization mode on the API server to enable the RBAC authorization model, which is default set for the current the Kubernetes releases. You can also configure RBAC for kubelets by including the node authorization in the authorization mode, and also you can remove any excessive permissive policies that is being set for a user for running an application. What that means, it means like you should already give at least permission to run an application. Specify roles and cluster roles whenever it's required for a group of users, and avoid duplication of the permissions in this case. Next comes is really securing the kubelet. So kubelet is really the entry point for managing the container workloads as it's managing the life cycle. And so you should apply a very strict rules or policies so that no malicious code can get access to that cluster. Okay, because once it gets access to a container, it really get access to a host cluster also. You should basically disable anonymous access with anonymous auth set to false, so that unauthenticated requests are not accepted anyway. You always ensure that requests are set by setting authorization mode to something always allow, and limit the permission of the kubelet by including the node restrictions through an admission control policies. Next is about setting, running your HCD. HCD as the primary database for managing the Kubernetes cluster, where it contains all the configuration of the cluster. So you should ensure that HCD should be configured, and it should have a TLS certificate configured for the authenticating between the peer components. Like in a production environment, you can have a two HCD running on an HA modes. And also you can set by setting certain firewall policies by setting cert file and key file to enable HTTPS connection to HCD. You can also set to use the trusted CA file certificates by specifying that trusted CA file and cert client cert authenticate to ensure that only the certificate, the authenticate certificates can be accessed by the HCD component. And also you require peering nodes, like other nodes in the control plane which are communicating with the HCD, to communicate using the peer client cert auth tool so that it communicates on a secure manner. And set auto TLS to false so that you don't run using self-signed certificates. And also you can use the HCD cert file and the key file so that the API server, the Kube API server, which is talking to the HCD, can able to authenticate itself. That is one of the primary important aspect here. Then you can manage the service account. So service account is one of the way where you define the set of actions that can be done on the Kubernetes cluster. And so service account entitles to create a secret on the Kubernetes cluster. The default way is basically don't auto mount this service account, the default service account, okay, and set it to false in the pod spec policies. And also the best practice is that use always a new service account for any deprecation for any application that is deployed. So don't use the default service account, because the default service account may have the excessive privileges which the application don't need while running into the cluster. Next is about restricting the network access. Network access is something where we need to ensure that in both the way, the ingress traffic as well the egress traffic should be controlled. Specifically, we should ensure that this network policies are monitored. And in the Kubernetes environment, this is done using this pod selector. So pod selector determines that what kind of policies are set for your pod to run on the Kubernetes cluster. And here you mentioned that for an ingress traffic, you should allow certain pods, not all the pods to be open. Specifically, the best practice says that you start denying all the traffic in the namespace and only allow those routes specific to an application which is required for your application to run. And also you try to restrict the cloud metadata API access to the network policies, which are generally in open by default. Also, you can configure the deep packet inspection that basically inspect the layer 7 layer 7 on the layer 7 for any malicious XML object that can really get deployed onto our cluster. So that is one of the very good way of managing that you don't end up injecting malicious code into the networking configurations. And also the next thing that is important thing comes is disabling the or running workloads with least privilege. So here you will provide the Linux kernel of running some of the security extension in terms of the capabilities, SLinux and AppArmor, which configures or which can be configured to provide least privilege, and it helps you to harden the cluster configuration. That is all about. And also you can use the service request and limit feature to limit the amount of resources that your user can use, and that is already defined through the resource quota. You utilize the seccomp, have the read-round mount access and minimal, and use a stripped down OS to reduce the service area for attack while deploying the application. And also the best way is that you always update the system patches and also run CS security benchmark test. So if you if there is any vulnerability that is introduced, you should immediately update the corresponding OS within the application and then redeploy the application. Next comes about securing the container images. So securing the container images is all about ensuring that you don't end up giving too much access to the user who would be accessing the application. So that way you really prevent the attacker to exploit or gain remote access to the containers. So there are different container management tools which helps you to basically scan your images for any vulnerability before they've been actually deployed, and that can also help you to disclose any major CVE. So that is very much important, and that should be deployed in an idle production environment. So tools such as Clear provide the image scanning, Notary uses signing to preserve the integrity. Even if you're running Docker, Docker has the Docker trusted registry, which helps you to enable and use only secure only those images which has been scanned thoroughly for any vulnerabilities before being passed into the environment. Whatever the registry solution, you use basically the read account for allowing those registries to act on your environment. So also you should not give full access to those account names. And also you use the images by giving or passing the SHA-1 information rather than not using the latest tag. Or if you know, you can basically use a specific tag to use it. And that condition, always pull images, should actually be used for every image that has been pulled into an environment, so that it always get the latest image. And you should not really compromise with any existing image that in the cluster which maybe have been already compromised. So how we can run containers securely? We can say no to root. We should not run directly as a root user, because that gives you excessive privilege to run any or trigger any actions on the cluster end. And next, the thumb rule is basically configuring the pod security policies, so that it uses the non-root user that prevents binding to the privilege port number, which is 1024. And this is really used normally for the kernel capability. So this is gated by the capnet bind service kernel capability. So you always try to use the must run as not root policy to prevent any escalation as a root user. Next comes is how you are able to manage the secrets effectively. So Kubernetes secrets really already contains certain secret and sensitive data that needs to be protected, and those informations can be encrypted both at rest as well as in transit. Okay, so you can use secret values that can be stored, and so ideally whenever we are passing the secret information through the environment, we should not directly pass it as a file parameter. Rather, we mount it on a volume and pass it where it can be encrypted at rest. Or we can basically use with any third-party tools such as the security tools such as Key Vault from HashiCorp or Conjure from CyberArk, which can be managed together with the etcd. And secrets should ideally not be passed into the build image, or it should not be passed as an environment variables directly into the image section where we are passing. Okay, because that allows you to get the information directly from the environment itself. And you should always try to do a periodic rotation and revocation of secrets as and when is used. So it basically prevents any misuse of the secrets by the attackers quickly. Next comes about securing your host machines, and that is important because ultimately you are running all your applications and deployments on the host machines. So if the host machines, it's compromised, all bad things can happen, because you basically give away ending up accessing the kernel of the operating systems. They can access the disk, network, everything. So you prevent escalations to the root, manage the secrets which are used for securing the application infrastructure access. So you should not provide them directly. You should always try to change the cluster admin privileges as often as required. And also you use any particular software. And when you're using those softwares for mining or determining any host vulnerability, usually use them with less privilege. So this is something called as a kill chain that really weaponize, exploit, and then take control of your inter cluster. And node recycling is one of the process through which you bring more capability in your existing cluster to cope through the node failure. And implementing a robust sandboxing and runtime protection is obviously required. The one way that can be you can use to work with is achieving a multi-tenancy on a non-trusted network. So then what are the factors here? So, well, if I think about managing the services, then service mesh is the future here, because it offers the possibility of communicating with individual services on a mutual TLS encryption. Okay, and those connections are secure end to end, and that is providing a zero trust network where you ensure that both the parties talk with one another. And it is not only just for allowing the service communication, you can do certain load balancing, and also you can enable other services to talk with the same component identically. And so, yeah, so service mesh is the future where we should ideally be headed to. Okay, so really when we talk about so many vulnerabilities that can get introduced in the on the component level, we formulate a kind of a and this framework is very well defined by the Mitre Attack, which is one of the web security framework that is tells like how security invasion, or basically content privilege escalation can happen. Right, it starts from the initial access side, and what are the phases actually that we should take into account where those invasion can happen. So first is about the initial access, where it already take into account all the periphery of your cloud infrastructure regarding the cloud credentials. If you're saving the images into your private registry or public registry app, and the dashboard side execution is basically once something goes inside a container, how it behaves, like how a particular command can go and compromise the entire cluster, right? So so those commands are bad commands, and we should try to avoid them. Then the next, which is kind of a backdoor container, or if there is any loopholes from where there has been a specific injection that has happened, which can basically compromise the cluster. Privilege escalation is something which we discuss, that we always end up giving using the default policies or the default users. Let's say, well, basically running an application with a service account, we always give up with the default service account, but we should always try to give or create a service account for that specific application. And that can relate to the host path mount, the accessing the cloud resources. Defense evasion is clearing the container logs, deleting any such events, and pod container name similarity. So basically, these are something, the runtime events. Okay, so we should not burden our host node with excessive logs that is required. We should try to prune them on where basically we on a monthly basis or on certain time frames, so that we can store them securely. Credential access is the list of all credential that can be accessed. It includes the secrets, it includes the service accounts also, and we determines that how the credentials in the configuration files are being stored. Discovery is something that is more on the API level, like how the KTS discovery, like the Kubernetes API can be discovered in terms of the accessing the API or modifying the API call by morph API morph API that can actually create security havoc. And also it also relates to different accessing the metadata instance from the dashboard side, the network mapping side. Lateral movement. Lateral movement is more about accessing accessing the data across different nodes within the cluster, whether it's creating an internal cluster networking you are creating, or writing the mount volume mount on the host machines, or accessing the dashboard, or even accessing the killer endpoint of an Helm deployment. So how that can affect, that is it. And impact is what are the impacts? Like the impacts is basically you will lose the data gets destroyed, and the resource get hijacked. The node on the node level it gets hijacked. Even your entire data center can get compromised because of that, and you leads to a denial of service. So you are not really allowed to access your services that you are running. So there are different tools and technologies that can actually help us to in our journey in basically securing the cluster. And this can be put down into three different areas. One is about the image security, one is the environment hardening, and third is the secret management. Managing how the images would be secured. I mean, that is what, like when you deploy an image onto your cluster, you should ensure that the image is thoroughly checked by your registry or by any other tools, as I was telling, like Claire or in case of Harbor, before it actually gets into the production. Because once it gets into the production, then it becomes very difficult to mitigate that attack. Environment hardening is all about making your clusters secure enough so that it can sustain any vulnerabilities or any malicious call that is targeted by the attackers towards your cluster. And like there are different benchmark tools which help us to mitigate that. One of the important is the Cube benchmark, which conform to the CIS benchmark category, and it's an open source tool which helps us to confirm whether the configurations that we have deployed for the Kubernetes cluster conforms to the standard policies, that is to the standard configuration that has been defined by this benchmark tool. So there's a set of tests that we can run against our cluster. Kube Hunter is one of the it's one of the we call as a penetration tool that help you to exploit any configuration in your cluster before it is being known by the attacker, and this way it helps you to go an extra one step ahead to modify your cluster properly so that it is secured actually. Then there is this open policy agent that defines a set of policies how your cluster would be accessed. You have Amazon Inspector from the Amazon Web Services, Turbot, and so these are all being provided, and it's very essential to use them effectively to manage our cluster securely. On the secret management side, we have, as I told you, that we can use the HashiCorp Vault that can get integrated with the etcd to store the secret information within the cluster. And that helps you to make the etcd more robust and help us to prevent any kind of attack on that HCD, because that is the critical component which is storing the entire configuration of the cluster. So in any way, the information should be secured and take precautions to mitigate attacks against the hackers or any other malicious users. So these are some of the reference that I use to get the data. And what I think security plays a very key role in our day-to-day in our day-to-day work, and not only from implementing security in managing a Kubernetes cluster, it does applies to the entire cloud native ecosystem where you are deploying each of the components, and you should ensure that not only the call which is made to a component is secure, but also the data which has been injected or the repositories that we are accessing, cloning into our system to access certain data is also secure, and there has not been much malicious content that has been put it into it. Okay, with that, I end my talk here, and I'm open to questions.